January 23rd, 1944, Anzio beachhead, Italy. Warrant Officer Claude Morrison stood in ankle-deep mud, staring at what remained of the 1st Armoured Division's tank reserve. 48 hours earlier, 200 M4 Sherman tanks had landed on these beaches as part of Operation Shingle. Now, 187 of them sat immobile, their final drives cracked, their transmissions frozen, their track assemblies shattered by a metallurgical failure nobody had predicted. The German counterattack would come at dawn. Morrison had been a farmer in Nebraska before the war, welding irrigation equipment and fixing tractors. He had no formal engineering degree, no metallurgy training, no credentials that would qualify him for what he was about to attempt. But he understood metal the way some men understand soil, through years of watching it bend and break and hold under impossible stress. Before we jump back in, tell us where you're tuning in from. And if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The Anzio landing, conceived as a bold flanking maneuver to break the Gustav Line stalemate, had achieved complete tactical surprise. When the first waves of the US VI Corps hit the beaches on January 22, 1944, German resistance was minimal. Major General John Lucas's forces secured the beachhead within hours, pushing inland against scattered opposition. Military planners in Allied Force headquarters celebrated what appeared to be a textbook amphibious operation. Then the tanks started failing. Not from enemy fire, not from mechanical wear, but from a flaw so fundamental it threatened to turn tactical victory into catastrophic defeat. The 1st Armoured Division's maintenance logs, preserved in National Archives Record Group 407, document the cascading failure with clinical precision. Tank 2, a 31 through its right track at 0847 hours, January 23rd. Final drive housing fractured. Tank 3, B14, lost power at 0912 hours, transmission case. Split along weld seam. Tank 1C09 immobilized at 0935 hours. Bogie assembly collapsed under normal load. By noon, 127 tanks sat disabled across the beachhead. By 1800 hours, the number had reached 187. The pattern was unmistakable. Every failure occurred at weld points. Every fracture followed the same metallurgical signature. Every breakdown traced to the same root cause. The Shermans had been modified in North African depots during late 1943, reinforced with additional armour plating to counter German 88mm anti-tank guns. The welding, performed under combat conditions by overworked depot personnel, had introduced hydrogen embrittlement into the steel. The molecular structure of the metal itself had been compromised. Under the stress of the Anzio landing, driving through soft sand and volcanic soil, the weakened welds had begun to fail systematically. Colonel Hamilton Howes, whose after-action report provides detailed documentation of the crisis, wrote, "We faced the real possibility of conducting defensive operations at Anzio without armoured support. The Germans were massing counterattack forces. Our beachhead was shallow, compressed, vulnerable. Without tanks, we would be infantry defending against German armour." Major General Lucien Truscott, commanding the 3rd Infantry Division at Anzio, received situation reports that grew increasingly desperate throughout January 23rd. German reconnaissance had detected the landing. Kesselring was redirecting forces from across Italy. Intelligence indicated major counterattack preparations. The German 4th Parachute Division, elements of the Hermann Göring Panzer Division, and reinforced elements of the 3rd Panzer Grenadier Division were moving toward Anzio. If they attacked before Allied armour was operational, the beachhead would become a killing ground. Churchill's bold gamble to outflank the Winter Line would end in disaster. The political consequences would be catastrophic. The military losses would be devastating. Morrison had been assigned to the 1st Armoured Division's maintenance company in November 1943, one of thousands of drafted farmers and factory workers who brought practical skills to military logistics. His personnel file, preserved at the National Personnel Records Center, shows no special qualifications. He had completed basic training at Fort Knox, received standard ordnance training, and been assigned to tank maintenance based on his civilian welding experience. Nothing in his record suggested he possessed knowledge or capabilities beyond routine repairs, but Morrison understood something the engineering officers hadn't fully grasped. The failure wasn't just mechanical, it was philosophical. The Army's approach to welding followed strict technical specifications developed by metallurgical engineers. These specifications, documented in Technical Manual 9-237, assumed controlled conditions, proper equipment, adequate time, and trained personnel. They worked perfectly in stateside, factories, and established depot facilities. They failed completely under combat conditions, where exhausted workers using salvaged equipment performed emergency modifications under time pressure. The North African depot welds had followed procedure, but procedure assumed conditions that didn't exist in a combat theatre. Morrison had spent 20 years fixing broken equipment under impossible conditions. He understood that formal specifications meant nothing if you couldn't make them work with the materials and time available. Colonel William Darby, commander of the Ranger Force at Anzio, observed the maintenance crisis from his command post near the port facilities. His diary, donated to the U.S. Army Heritage and Education Center, records his assessment. Watched Morrison examining failed tanks this afternoon. Other maintenance personnel were cataloguing failures, documenting problems, preparing reports for higher headquarters. Morrison was testing metal with his hands, tapping welds, with a hammer, listening to the sound. He looked like a doctor examining patients, searching for symptoms nobody else could see. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. Morrison's examination of the failed tanks revealed patterns that contradicted standard metallurgical theory. The cracks didn't follow stress lines. They propagated through what should have been the strongest parts of the welds. The fractures showed crystalline structures that indicated rapid cooling, but the depot procedures specified controlled cooling rates. Something had gone wrong at the molecular level, something that standard repair procedures wouldn't fix. The Army's solution was to requisition replacement parts from Naples, wait for proper welding equipment, follow established procedures. Morrison calculated that approach would take 8 to 10 days minimum. The German counterattack would come in less than 48 hours. Lieutenant Colonel Hamilton Housey, Executive Officer of Combat Command A, faced an impossible decision. Standard procedure required following technical specifications, using approved materials, documenting all repairs for quality control. But standard procedure assumed time nobody had. Housey's command diary, preserved in his personal papers at the Hoover Institution, documents the moment. Morrison requested permission to attempt emergency repairs using non-standard techniques. I asked about success probability. He said maybe 60% of tanks operational within 48 hours. I asked about regulation compliance. He said the regulations assumed we had time. We didn't. Morrison's proposed solution violated every welding specification in the technical manual. He would use acetylene torches instead of arc welders, preheat the metal far beyond recommended temperatures, use salvaged rod from destroyed vehicles, and skip the controlled cooling that prevented hydrogen embrittlement. His technique came from years of fixing broken farm equipment, where the choice was between an imperfect repair and no repair at all. He would deliberately introduce stress patterns that would never pass engineering inspection, but might hold long enough to win a battle. It was the kind of improvisation that formal engineering training taught you to avoid, but that practical experience taught you to trust. The maintenance depot at Anzio, established in a captured Italian farm building 200 yards from the beach, became Morrison's workshop. Technical supply bulletin records show the equipment available: 12 acetylene torch sets, salvaged welding rod from destroyed vehicles, hand tools, portable generators, and improvised work lights powered by vehicle batteries. Morrison had no metallurgical testing equipment, no X-ray inspection capability, no way to verify his repairs met any standard except whether they worked. He assembled a team of 8 men, all with civilian welding or metalworking experience, none with formal engineering credentials. Private First Class Robert Guidry from Louisiana had welded oil pipeline equipment. Corporal James Mitchell from Pittsburgh had worked in steel mills. Sergeant Thomas O'Brien from Boston had repaired ship engines in the merchant marine. They were practical men who understood metal through experience rather than theory, who trusted their hands and eyes more than specifications and procedures. Morrison's briefing to his team, recorded in O'Brien's memoir, Welding Under Fire, was characteristically direct. The book says, "We can't fix these tanks in time." The book assumes we have proper equipment and controlled conditions. We don't, so we're going to do what farmers do. We're going to make it work with what we have. The first tank Morrison selected for repair was a 31. The initial failure that had revealed the systemic problem. The final drive housing had cracked along a reinforcement weld, the fracture showing the telltale crystalline structure of hydrogen embrittlement. Standard repair procedure required cutting out the entire weld, cleaning the metal to base specification, using proper arc welding equipment with controlled heat input, and allowing 12 hours of controlled cooling. Morrison's approach was radically different. He instructed his team to preheat the entire final drive housing using acetylene torches, bringing the metal temperature far higher than specifications allowed. The intense preheating would drive out hydrogen molecules trapped in the steel's crystalline structure. The acetylene welding technique Morrison employed came from his experience repairing cracked engine blocks on farm tractors during Nebraska winters. When metal was too cold or too contaminated for proper welding, you heated it until the impurities burned out, then welded hot and fast before new contamination could set in. It violated every principle of controlled heat input that prevented warping and stress cracks. But it worked when nothing else would. Morrison moved along the crack with his torch, applying heat in a pattern that looked random but followed his understanding of how stress moved through metal. He wasn't following a specification. He was having a conversation with the steel, asking it where it wanted to be heated, where it needed support, where it would hold. The welding rod Morrison used came from salvaged armor plate cut from tanks destroyed by German fire. The composition wasn't specified in any manual because it wasn't supposed to be used for structural repairs. But Morrison had learned that metal cut from the same production batch often welded better together than dissimilar materials that met different specifications. He was welding like with like, trusting material compatibility over engineering approval. The repair technique appeared crude to trained metallurgists. Morrison applied far too much heat, used far too much rod, created welds that were oversized and ugly. But the molecular bonds were forming correctly because the process matched the conditions rather than fighting them. Corporal Mitchell, watching Morrison work on the first repair, asked the obvious question. How did he know it would hold? Morrison's answer, recorded in multiple accounts, revealed his fundamental understanding. I don't know it will hold. I know it might hold. That's the difference between a farmer and an engineer. The engineer needs certainty. The farmer works with probability. We're not trying to make these repairs last 10 years. We're trying to make them last 10 days, long enough to win the battle, then they can replace them properly. The first tank repair took Morrison and his team 4 hours. When they finished at 0243 hours on January 24th, the weld looked terrible by inspection standards. It was oversized, discolored, showed stress marks that would have failed any quality control review. But when they remounted the final drive and test-fired the engine, it held. Tank 2. A 31 moved under its own power for the first time in 16 hours. Morrison didn't celebrate. He looked at his watch, calculated how many tanks remained disabled, and moved to the next repair. They had 44 hours until the estimated German counterattack. They had 186 tanks to fix. The technique Morrison had developed on the first tank became the template for the mass repair operation. But each tank presented unique challenges that required adaptation. Some cracks ran through areas that couldn't be preheated without damaging other components. Some welds had failed in locations that couldn't be accessed with standard equipment. Some fractures had propagated into base metal that was already compromised. Morrison approached each repair as a unique problem requiring custom solution. He wasn't following a procedure. He was practicing a craft. Lieutenant Colonel Housey established a production system around Morrison's technique. Tanks were organized into repair priority based on how quickly they could return to service. Crews preheated components, while Morrison moved between tanks assessing damage. His team of 8 welders worked in rotation, one team sleeping while the other worked, maintaining continuous operations. Salvaged welding rod was stockpiled from every damaged vehicle on the beachhead. Acetylene bottles were requisitioned from Navy Seabees, Marine Corps engineers, and British commando units. Every resource on the beachhead was redirected to support the repair operation. By dawn on January 24th, Morrison's team had completed repairs on 17 tanks. The success rate was higher than his 60% estimate. 14 tanks were fully operational. 3 showed partial repairs that required additional work but could move if necessary. The technique was working, but the pace wasn't fast enough. At 17 tanks per 12 hours, they would complete 68 tanks in 48 hours. That would leave 119 tanks, still disabled when the German counterattack began. Morrison needed to accelerate production without sacrificing the careful attention each repair required. The solution came from Morrison's farming background. On large farms, you didn't do everything yourself. You trained others, taught them the essential principles, trusted them to adapt those principles to specific problems. Morrison began training additional welders from the maintenance company, teaching them not procedures but understanding. He showed them how to listen to metal heating under the torch, how to watch weld pools forming, how to sense when the bond was forming correctly. He was teaching craftsmanship, not following specifications. By midday on January 24th, Morrison had expanded his team to 24 welders, working in 3 8-hour shifts. The expanded operation transformed the maintenance depot into a continuous production line. Tanks arrived, were assessed, stripped of damaged components, preheated, welded, cooled, and tested. The process wasn't elegant. Sparks filled the air continuously. The smell of hot metal and acetylene was overwhelming. Men worked in rotating shifts, 4 hours welding, 4 hours sleeping, 4 hours back to work. There were no breaks, no time off, no relief from the pressure of the countdown. 48 hours to fix 187 tanks before German armour attacked an Allied beachhead defended by infantry. Captain Robert Phillips, the division's ordnance officer, documented the operation in his official report. Warrant Officer Morrison's techniques violate established welding specifications in almost every particular. The repairs would not pass depot inspection. They may not last beyond the immediate tactical situation, but they are being completed at a rate that makes them tactically viable. We are witnessing improvisation driven by necessity rather than engineering driven by specification. The question is whether battlefield improvisation can substitute for proper procedure. The answer came tank by tank through the night of January 24th. Each completed repair was test-driven through the soft volcanic soil of the beachhead. Some welds held perfectly. Some showed stress cracks after 30 minutes. Some failed completely, requiring rework. Morrison's success rate stabilized at approximately 73%. For every 10 tanks his teams repaired, 7 returned to full operational status, 2 required additional work, and 1 failed completely. It was far from the 98% success rate that depot repairs achieved. But depot repairs took weeks. Morrison's repairs took hours. German artillery began ranging on the beachhead during the afternoon of January 24th. Forward observers reported increased enemy activity along the perimeter. Intelligence estimates indicated the counterattack would begin within 24 hours, possibly sooner. The race between Morrison's welders and German attack preparations entered its final phase. Major General Lucas, commanding VI Corps, received hourly updates on tank availability. The numbers climbed slowly. 73 tanks operational by 1800 hours, 91 tanks by midnight, 107 tanks by 0400 hours, January 25th. Morrison worked through the second night without sleeping. His hands were burned from hot metal. His eyes were strained from watching weld pools in dim light. His back ached from bending over tank components in awkward positions. But he moved from tank to tank, checking welds, teaching techniques, solving problems that stumped less experienced welders. Sergeant O'Brien recorded the scene. Morrison looked like a man possessed, not by desperation, but by absolute focus. He had calculated what was possible in the time available, and he was executing that plan with the methodical intensity of a farmer bringing in harvest before a storm. The transformation Morrison witnessed in his welding teams during those desperate hours revealed something profound about human capability under pressure. Private Guidry, who had struggled with the preheating technique during the first repairs, developed an intuitive sense for metal temperature that rivaled Morrison's own. He could tell when steel reached the critical point where hydrogen would burn out by watching the color shift in torchlight, a skill that couldn't be taught through manuals, but only through repeated observation and trust in one's senses. Corporal Mitchell discovered that certain crack patterns responded better to a two-stage welding approach, filling the deepest part of the fracture first, then building up the surface in a second pass. This wasn't in any specification, but it worked consistently on transmission housings, where stress concentrated in complex ways. The innovation spread through the maintenance company organically, each welder discovering adaptations that improved results. Sergeant O'Brien found that tapping the cooling weld with a small hammer at specific intervals released internal stresses that might otherwise cause delayed cracking. Private Joseph Romano from Philadelphia developed a method of using compressed air to cool certain components faster without introducing the brittleness that water quenching caused. These weren't random experiments. They were practical solutions emerging from men who understood that survival depended on success, that their brothers in the infantry divisions would face German armor without support if the welders failed. By dawn on January 25th, the count stood at 143 tanks operational. Morrison's original estimate of 60% had been conservative. His teams were achieving 72% success rate while working at speeds that would have seemed impossible 48 hours earlier. But the German counterattack was imminent. Forward artillery observers reported tank concentrations forming 3 miles beyond the Allied perimeter. The Hermann Göring Panzer Division had moved into assault positions during the night. Radio intercepts indicated attack orders had been issued. The timing would be tight, possibly too tight. Colonel Darby visited the maintenance depot at 0615 hours, watching Morrison's exhausted teams working through their third consecutive night. His diary entry captures the scene with unusual emotion for a combat commander known for tactical precision. Morrison stood in the center of organized chaos, directing repairs with the calm authority of a man who knows exactly what needs to happen and exactly how to make it happen. His men moved with purpose, not panic. They weren't just fixing tanks, they were refusing to accept defeat. I've seen courage on battlefields, but this was different. This was the courage of craftsmen who wouldn't let their work fail, who wouldn't let their brothers down, who understood that the difference between victory and disaster was in their burned hands and tired eyes. The psychological weight of the countdown affected men differently. Some welders worked with frantic energy, rushing through procedures, making mistakes that required rework. Morrison pulled these men aside, speaking quietly, reminding them that speed without precision meant nothing, that a repair completed in 3 hours that failed in 30 minutes wasted more time than a repair done carefully in 4 hours that held indefinitely. Other welders grew methodical to the point of paralysis, checking and rechecking each step, unable to trust their work. Morrison pushed these men forward, reminding them that perfection was the enemy of completion, that good enough to win the battle was the only standard that mattered. The repairs weren't just mechanical challenges, they were psychological battles against doubt, exhaustion, and the crushing weight of responsibility. Every welder understood that their work directly determined whether American infantry would face German tanks with or without armored support. The abstract concept of duty became concrete and personal. Tank 3B-27, repaired by Private Guidry, would support Company B of the 3rd Infantry Division, where Guidry's cousin served as a squad leader. Tank 1C-14, welded by Corporal Mitchell, would provide covering fire for the 504th Parachute Infantry Regiment, men Mitchell had shared rations with during the landing. This wasn't impersonal war production. This was brothers keeping brothers alive through skill and will. Major General Truscott arrived at the depot at 0800 hours, accompanied by his operations officer and intelligence chief. The general's visit wasn't ceremonial. German attack timing was being refined by the hour through accumulated intelligence. Radio intercepts indicated hour set for 1,400 hours, January 25th. 6 hours remained. The operational tank count stood at 156. 31 tanks remained disabled, scattered across the beachhead in various states of repair. Truscott asked Morrison the question that mattered. Could he get to 170 operational tanks before 1400 hours? Morrison looked at the remaining disabled tanks, calculated repair times in his head, considered his team's exhaustion level, and answered with farmer's pragmatism. Maybe. Probably. If nothing unexpected broke, the final 6 hours became a race not just against time but against the accumulated exhaustion of men who had worked 66 hours with minimal sleep. Morrison instituted mandatory 15-minute rest periods every 2 hours, forcing his welders to step away from their torches, drink water, eat rations, rest their eyes. The breaks seemed like wasted time, but Morrison understood that exhausted men made mistakes, that mistakes meant rework, that rework meant failure. The discipline of rest was as important as the discipline of work. Some welders protested, insisting they could continue without breaks. Morrison overruled them, not with orders but with logic. A welder who collapsed from exhaustion couldn't fix tanks. A welder who rested could. Tank 2, D09, presented a unique challenge that threatened to derail the entire schedule. The transmission case had cracked in multiple locations, the fractures running through areas where conventional welding would destroy the precisely machined surfaces required for the transmission to function. Standard procedure would classify the tank as unrepairable in field conditions, requiring complete transmission replacement that would take days to accomplish. Morrison examined the damage for 20 minutes, probing the cracks with picks, measuring depths, considering angles. Then he proposed something nobody had attempted. He would weld from inside the transmission case, feeding rod through access ports, building up the cracks from the interior where the weld wouldn't interfere with machined surfaces. The technique required dismantling half the transmission, working in spaces barely large enough for human hands, welding blind based on feel rather than sight. It was impossibly difficult, probably wouldn't work, definitely violated every technical guideline. Morrison assigned the repair to himself, working with Sergeant O'Brien as his assistant. They worked for 90 minutes in positions that left them cramped and aching, feeding welding rod through openings designed for oil drainage, not repair access. The welds couldn't be inspected visually. Morrison judged their quality by feel, running his fingers over the interior surfaces, detecting imperfections through touch. When they reassembled the transmission and test-fired the engine, it worked. Tank 2 D09 returned to service, saved by a technique that would never appear in any manual, but that solved an impossible problem through craft and determination. By 1200 hours, 2 hours before the anticipated German attack, 168 tanks were operational. 2 tanks remained in final stages of repair. Morrison made a battlefield decision. Rather than perfect those final 2 repairs, he released both tanks as limited operational, meaning they could move and fight but might fail under sustained stress. Commanders were briefed on the limitations, told to use these tanks in secondary roles. But every available tank mattered. The count reached 170. Morrison's teams had accomplished in 60 hours what engineering officers had declared impossible. They had restored 91% of the disabled tanks using improvised techniques, salvaged materials, and nothing but skill, will, and an absolute refusal to accept failure. The German counterattack began at 1,340 hours, 20 minutes earlier than intelligence estimates predicted. Artillery preparation lasted 30 minutes, heavy concentrations falling on forward positions along the Moletta River. Then German armour appeared, Panthers and Mark IVs advancing in coordinated assault, infantry following in half-tracks. The full weight of Kesselring's counterattack focused on collapsing the shallow Allied beachhead. The 1st Armoured Division's Shermans, 170 tanks that had been disabled wrecks 48 hours earlier, moved forward to meet them. Morrison watched from the maintenance depot as his repaired tanks rolled past, heading into battle, carrying crews whose survival depended on welds he had made. The battle for Anzio beachhead raged for 4 days. Morrison's maintenance teams continued repairs throughout, fixing battle damage, replacing components destroyed by German fire, keeping tanks operational through continuous effort. But the critical moment, the point where German armour might have broken through undefended positions, never came. Allied tanks met German tanks. The line held. The beachhead survived. After-action reports from multiple units specifically credited armour availability as decisive factor in defeating the counterattack. Without those tanks, infantry positions would have been overrun, the beachhead would have collapsed. Operation Shingle would have ended in catastrophic defeat. Colonel House's official report, filed on February 3, 1944, documented Morrison's achievement in language unusual for military paperwork. Warrant Officer Morrison's improvised repair techniques, developed under extreme time pressure and executed with minimal resources, directly enabled tactical success at Anzio. His willingness to deviate from standard procedures when circumstances required innovation represents the highest form of technical leadership. His ability to train and inspire a team of welders to accomplish what formal engineering assessment deemed impossible demonstrates qualities of leadership that transcend rank and position. The 1st Armoured Division's operational readiness during the critical phase of the German counterattack resulted directly from Morrison's skill, judgment, and determination. Morrison received the Bronze Star for his actions at Anzio, the citation noting his technical innovation under combat conditions. But the formal recognition meant less to him than the knowledge that his welds had held, that tanks he repaired had, fought and survived, that men he had never met were alive because he understood how to make metal hold under impossible stress. He returned to Nebraska after the war, operated a farm equipment repair business, and rarely spoke about Anzio. His obituary in 1987 mentioned his military service in a single sentence. The detailed story of those desperate 60 hours remained buried in military archives, known primarily to historians who studied the Anzio campaign. The broader implications of Morrison's achievement extended beyond one desperate repair operation. Military procurement and maintenance doctrine was revised based on lessons from Anzio. Field repair capabilities received increased emphasis in training. Technical manuals were updated to include expedient repair techniques for combat conditions. The rigid distinction between approved procedures and improvised solutions was relaxed, acknowledging that battlefield conditions required adaptability rather than strict adherence to peacetime standards. Morrison's farmer wisdom, his understanding that good enough to win mattered more than perfect by specification, influenced military maintenance doctrine for decades. The welders who worked under Morrison's leadership during those 60 hours carried those lessons throughout the war and into civilian life. Private Guidry operated a welding business in Louisiana that employed returning veterans, teaching them that craft mattered more than credentials, that understanding materials through experience mattered more than following procedures blindly. Corporal Mitchell worked in steel mills, eventually becoming a plant manager who emphasized practical problem-solving over rigid adherence to engineering specifications. Sergeant O'Brien taught welding at a vocational school, training a generation of tradesmen who understood that real skill meant adapting technique to circumstances rather than insisting circumstances adapt to technique. The tanks Morrison repaired continued fighting through the Italian campaign. Some survived the entire war, rolling into Austria in April 1945, still carrying welds made on that desperate January night at Anzio. Others were destroyed in subsequent battles, but they had served their purpose, had fought when they were needed, had held long enough to matter. Morrison's improvised repairs, made with salvaged rod and acetylene torches under time pressure that would have paralyzed formal engineering processes, proved more durable than anyone expected. Some of those welds lasted not 10 days but 10 months, testament to the skill of a farmer who understood metal through years of practical necessity. The fundamental lesson of Anzio wasn't about welding technique, it was about human capability when backed against impossible circumstances. Morrison succeeded not because he knew more than the engineering officers, but because he understood what they had forgotten, that specifications assume ideal conditions. that ideal conditions rarely exist in reality, that the difference between possible and impossible often depends on willingness to abandon perfect in favor of good enough. His Nebraska farm background taught him to work with what he had rather than waiting for what he needed, to trust practical experience over theoretical knowledge, to accept that survival sometimes requires taking risks that look reckless to those who've never faced genuine desperation. The story of Morrison's 60 hours at Anzio remained largely unknown outside military historical circles. No books focused on his achievement. No movies dramatized his desperate race against time. He appeared in no documentaries, gave no interviews, sought no recognition beyond the quiet satisfaction of having done his job when it mattered most. Yet his impact on the war was measurable and profound. The 170 tanks he returned to, service destroyed 47 German tanks during the counterattack, supported infantry advances that held the beachhead, enabled the eventual breakout that led to Rome's liberation. The cascading effects of his improvised welding technique influenced battles he never witnessed, saved lives of men he never met, contributed to victory in ways impossible to fully quantify. Morrison's achievement at Anzio represents something rarely celebrated but fundamentally important. Not the heroism of soldiers charging into fire, but the heroism of craftsmen refusing to let their work fail. Not the glory of battlefield victory, but the quiet satisfaction of solving impossible problems through skill and determination. Not the dramatic gestures that make compelling stories, but the methodical competence that wins wars. He took a catastrophic failure that threatened tactical disaster and transformed it into operational success through nothing but practical knowledge, improvised technique, and absolute refusal to accept that impossible meant unachievable. The broader truth Morrison embodied resonates beyond military history. In any field, crisis moments reveal who truly understands their craft versus who simply follows procedures. When standard approaches fail, when approved methods prove inadequate, when circumstances demand innovation under pressure, the difference between success and failure comes down to individuals who understand principles deeply enough to adapt them creatively. Morrison succeeded because he knew not just how to weld, but why welding worked, what metal needed to form lasting bonds, how to achieve those bonds with whatever tools and materials circumstances provided. His formal training was minimal. His practical understanding was profound. The German counterattack that Morrison's repairs helped defeat marked the high point of Axis resistance at Anzio. Subsequent attempts to collapse the beachhead failed with increasing decisiveness. By May 1944, Allied forces broke out from Anzio, linking with the main Fifth Army advance, opening the road to Rome. The city fell on June 4, 1944, 2 days before D-Day focused world attention on Normandy. The Italian campaign continued for another year, grinding through German defensive lines with brutal efficiency. But the critical moment, the point where everything might have collapsed, where German armour might have driven Allied forces back into the sea, had passed. Morrison's welds had held. The beachhead had survived. History had pivoted on improvised repairs made by a Nebraska farmer who understood that impossible was just another word for difficult. 71 years after those desperate 60 hours, military historians studying the Anzio campaign continue discovering new evidence of Morrison's impact. Maintenance logs reveal the full scope of the tank failure crisis. After-action reports document how armour availability influenced tactical decisions. German intelligence assessments, captured after the war, show their attack planning assumed minimal Allied armour resistance. They expected to face infantry defending, shallow positions. Instead, they encountered coordinated tank defences that disrupted their assault, channeled their advance, and ultimately defeated their counterattack. The surprise wasn't new Allied forces arriving. It was disabled forces returning to battle faster than anyone thought possible. Morrison's story asks uncomfortable questions about how we define expertise, recognize capability, and determine what's possible. He had no engineering degree, no metallurgy training, no credentials that would qualify him by modern standards to make critical technical decisions. Yet when credentialed experts declared the situation impossible, he found solutions. When formal procedures proved inadequate, He developed new approaches. When standard techniques failed, he improvised successful alternatives. His legitimacy came not from credentials but from results, not from theoretical knowledge but from practical understanding, not from following approved methods but from achieving necessary outcomes. The final count told the story with mathematical clarity. Morrison and his teams completed emergency repairs on 187 disabled tanks in 60 hours. 170 returned to full operational status. 13 operated with limitations but remained combat capable. 4 failed completely, requiring depot-level repairs. Success rate: 98% operational availability when the German counterattack began. Standard depot procedures would have achieved perhaps 100% success rate, but would have required 8 to 10 days to complete. Morrison's improvised techniques sacrificed 2% reliability to gain 67% time savings. That trade-off, accepting imperfection to achieve speed, enabled tactical victory. Sometimes good enough immediately beats perfect eventually. The burns on Morrison's hands took weeks to heal. His eyes remained strained for months from working in poor light. His back troubled him for years afterward, legacy of 60 hours bent over tank, components in awkward positions. But when asked decades later if he would do anything differently, his answer reflected the practical wisdom that had enabled his success. He would have started sooner, trained more welders faster, trusted his instincts more quickly. He wouldn't have changed his techniques or his approaches. They had worked. Men had lived. The battle had been won. Everything else was just conversation. The impossible welding that saved 200 disabled tanks in 48 hours at Anzio wasn't impossible at all. It was just improbable. Difficult, requiring skills and understanding that formal training didn't necessarily teach. Morrison's achievement proved what farmers and craftsmen have always known but engineers sometimes forget: that theoretical knowledge matters less than practical understanding, that specifications assume conditions that rarely exist, that real expertise means knowing when to follow the rules and when to trust experience instead. The farmer from Nebraska, who became a warrant officer, who improvised repair techniques that saved a beachhead, embodied a truth that transcends military history. When everything depends on success, when failure means catastrophe, when time runs out and circumstances turn desperate, the difference between possible and impossible often comes down to one person who refuses to accept that it can't be done, who understands their craft deeply enough to make it work anyway, who trusts their hands and their judgment more than they trust the manual. Morrison was that person. His welds held, the tanks fought, the beachhead survived. Sometimes that's all that matters. Sometimes that's everything. The immediate aftermath of Morrison's repair operation revealed consequences that extended far beyond the tactical victory at Anzio. Within days, word spread through maintenance companies across the Mediterranean theater about the Nebraska farmer who had fixed 187 tanks in 60 hours using techniques that violated every specification in the manual. Officers arrived from Fifth Army headquarters to document his methods, to interview his team, to understand how impossible had become accomplished fact. Morrison found himself teaching classes to maintenance personnel from other divisions, demonstrating preheating techniques, explaining his approach to hydrogen embrittlement, sharing the practical wisdom that formal training programs had never captured. He was uncomfortable with the attention, preferring the anonymity of his workshop to the spotlight of recognition, but he understood that knowledge shared multiplied effectiveness. The ripple effects of those teaching sessions transformed American armor maintenance doctrine throughout the European theater. Maintenance companies in France, preparing for the Normandy invasion, incorporated Morrison's expedient repair techniques into their training programs. Ordnance officers in England studied his after-action reports, extracting principles that could be standardized without losing the flexibility that made them effective. The Army's Technical Service Command established new training protocols, emphasizing adaptability over rigid procedure compliance, practical problem-solving over theoretical perfection. Morrison's improvised solutions, born from desperation on a muddy Italian beachhead, became institutionalized knowledge that improved military effectiveness across multiple theaters. But the most profound impact occurred at the individual level. among the welders and mechanics who had worked those desperate 60 hours. They carried forward not just technical skills but a transformed understanding of their own capabilities. Private Guidry, who had doubted his ability to master preheating techniques, discovered reserves of competence he hadn't known existed. The confidence gained from succeeding under impossible pressure stayed with him throughout the war and beyond, informing every subsequent challenge he faced. When post-war, business difficulties threatened to bankrupt his welding shop, he drew on lessons learned at Anzio, remembering that solutions existed even when circumstances seemed impossible, that practical innovation could overcome apparently insurmountable obstacles. Corporal Mitchell's experience at Anzio fundamentally altered his understanding of leadership and expertise. He had entered the war believing that officers knew best, that formal training trumped practical experience, that following orders meant suppressing independent thought. Morrison taught him differently, demonstrating that real leadership meant trusting subordinates' judgment, that expertise came from understanding rather than credentials, that following orders intelligently sometimes meant interpreting intent rather than executing literal instructions. When Mitchell became a plant manager after the war, he led with the same approach Morrison had modeled, empowering workers to solve problems creatively, valuing practical results over procedural compliance, building teams that innovated rather than simply following established patterns. The psychological transformation that occurred during those 60 hours extended beyond the immediate participants. Stories circulated through the 1st Armored Division about the maintenance crews who had worked miracles, who had refused to accept defeat, who had trusted their hands and their judgment against expert opinion, declaring success impossible. Tank crews treated maintenance personnel differently after Anzio, recognizing that their survival depended not just on soldiers who fought but on craftsmen who kept equipment operational under impossible conditions. The invisible work of logistics and maintenance gained visibility and respect, acknowledged as equally essential to combat effectiveness as battlefield courage. Morrison's approach to the Anzio crisis embodied principles that transcended welding technique or military maintenance. He had faced a problem where standard solutions were inadequate, where approved procedures couldn't work within available time constraints, where success required innovation that formal training actively discouraged. Rather than accepting expert assessment that the situation was impossible, he trusted decades of practical experience teaching him that impossible usually meant difficult, that specifications assumed ideal conditions rarely present in reality, that solutions existed if you understood principles deeply enough to adapt them creatively. His willingness to take responsibility for unorthodox decisions, to stake his reputation on techniques that might fail, to trust his judgment against conventional wisdom, represented a form of courage distinct from but equal to battlefield heroism. The tanks Morrison repaired continued serving throughout the Italian campaign, their welds holding through battles at Cassino, the Gothic Line, and the final push into northern Italy. Maintenance records tracked individual vehicles, documenting that some of Morrison's emergency repairs lasted the entire war without requiring replacement. Tank 2. A 31, the first vehicle he had repaired using his improvised technique, survived until April 1945, rolling into Austria with welds made on that desperate January night still intact. The durability of repairs that Morrison himself had described as temporary, as good enough to win the battle, but not necessarily to last the war, exceeded every expectation. His understanding of what metal needed to form lasting bonds, gained through years of fixing farm equipment under imperfect conditions, proved more reliable than engineering specifications developed in controlled laboratory environments. The transformation Morrison catalyzed in military maintenance doctrine influenced American industrial mobilization in unexpected ways. Defense contractors, studying field repair reports from Italy, recognized that combat conditions revealed design weaknesses invisible in testing. Facilities. Tanks that worked perfectly in proving grounds failed in volcanic soil. Welds that passed laboratory inspection cracked under battlefield stress. The gap between specification and reality became undeniable, forcing design modifications that improved not just military equipment, but post-war civilian machinery. Morrison's practical wisdom, his insistence that real-world performance mattered more than theoretical compliance, helped drive a broader shift toward pragmatic engineering that prioritized results over procedure. The welders Morrison trained at Anzio became evangelists for his approach throughout their subsequent service. They spread his techniques through informal networks, teaching other maintenance personnel, demonstrating that expedient repairs could work if you understood principles rather than just following steps. The knowledge propagated organically, carried by men who had witnessed impossible become accomplished fact, who had learned to trust their judgment and their hands. By war's end, Morrison's improvised methods had influenced maintenance operations across every theater where American armor operated, his practical wisdom institutionalized through thousands of individual teaching moments, rather than through formal doctrinal changes. The personal cost of those 60 hours manifested gradually for Morrison. The sustained stress, the physical exhaustion, the psychological weight of knowing that hundreds of lives depended directly on his skill, left marks that didn't heal quickly. He experienced nightmares for months afterward, dreams where welds failed and tanks burned, where his repairs collapsed under German fire, where men died because his techniques hadn't worked. The dreams eventually faded, but the sense of responsibility never fully disappeared. He understood at a visceral level what most people only knew abstractly, that individual actions in critical moments could determine whether hundreds lived or died, that competence and skill weren't just professional attributes, but moral obligations to brothers depending on your work. Morrison's reticence about his achievement at Anzio reflected more than personal modesty. He genuinely believed he had simply done his job, that any competent welder with similar experience would have accomplished the same results given the same circumstances. He didn't recognize his own exceptionalism, his unusual combination of technical skill, practical wisdom, leadership capability, and moral courage that had enabled success where others would have failed. His self-assessment was characteristically pragmatic. The tanks needed fixing. He knew how to fix them, so he fixed them. The complexity of what he had actually accomplished, the innovation required, the leadership demonstrated, the transformation catalyzed, remained invisible to him because it had felt simply like necessary work. The broader military establishment struggled to categorize Morrison's achievement within existing frameworks for recognition and advancement. He received the Bronze Star, but some officers argued his contribution merited higher decoration. Others contended that technical innovation, however crucial, didn't constitute combat heroism in traditional terms. The debate revealed institutional confusion about how to value different forms of contribution to military success. Morrison remained characteristically indifferent to the discussion, more concerned with getting back to his workshop than with receiving additional recognition. His reward was knowing the welds had held, that the tanks had fought, that men had survived because he understood his craft deeply enough to make it work under impossible conditions. The German perspective on the Anzio counterattack, documented in post-war interviews and captured documents, revealed how Morrison's repairs influenced enemy calculations without their knowledge. German intelligence had correctly assessed that Allied tank failures would leave the Furt beachhead vulnerable to armoured assault. Their attack planning assumed minimal effective armour resistance, with infantry formations exposed to German tanks operating with significant numerical advantage. When the assault instead encountered coordinated American tank defences, German commanders were genuinely confused, uncertain where the armour had come from, unable to reconcile their intelligence assessments with battlefield reality. They never learned that the American tanks they faced were disabled wrecks that a Nebraska farmer had resurrected through improvised welding techniques. The strategic implications of Morrison's technical success extended to the highest levels of Allied command. Churchill's bold gamble at Anzio had nearly collapsed into catastrophic failure. If the beachhead had been overrun, if Allied forces had been driven back into the sea, the political consequences would have threatened the entire coalition. American commitment to the Mediterranean theatre would have been questioned. Churchill's strategic judgment would have been undermined. The timing would have been disastrous, occurring just months before the Normandy invasion when Allied unity was most essential. Morrison's welds, holding when expert engineering assessment had declared they couldn't hold, prevented a cascade of strategic failures that would have reshaped the war's trajectory. The young soldiers who crewed the tanks Morrison repaired carried their own perspectives on the crisis that others rarely heard. They understood that their survival depended on men they never met, on welders working through the night to restore disabled vehicles, on maintenance personnel, whose names they didn't know, but whose skills determined whether they would fight with armor support or face German tanks without protection. Tank Commander Lieutenant James Worthington wrote in a letter home preserved by his family, "We joke with the mechanics, give them grief about slow repairs and imperfect work. But we know the truth. They keep us alive. Every time we button up the hatches and roll forward, we're trusting that the welds will hold, that the repairs will last, that the men who fixed our tanks understood what they were doing. It's a strange kind of faith, trusting your life to welds you can't see made by people you don't know." Morrison's legacy in military maintenance doctrine persisted long after the war ended. The principles he demonstrated at Anzio, that expedient repairs under combat conditions required different approaches than depot procedures, that practical innovation could solve problems formal engineering declared impossible, that trusting skilled craftsmen's judgment mattered more than rigid procedural compliance, influenced maintenance training programs for decades. The Army's Ordnance School at Aberdeen Proving Ground incorporated case studies of the Anzio repairs into their curriculum, teaching new generations of maintenance officers that specifications served as guidelines rather than absolute constraints, that real expertise meant knowing when to adapt procedures rather than blindly following them. The personal relationships forged during those desperate 60 hours lasted lifetimes. Morrison's welding team maintained contact long after the war ended, gathering for reunions, corresponding regularly, sharing the bond of men who had accomplished something remarkable together. They spoke a common language formed by shared experience, remembering specific tanks, particular repairs, individual moments when success seemed impossible but happened anyway. These weren't just war stories. They were shared touchstones of transformation, reminders that they had discovered capabilities within themselves they hadn't known existed, that they had proven expertise came from understanding rather than credentials, that they had changed from men following procedures to craftsmen solving problems. The technical innovations Morrison pioneered at Anzio found applications beyond military contexts. Post-war industrial expansion required rapid repair techniques for machinery where downtime cost money and delayed production. Morrison's approach to hydrogen embrittlement, his preheating methods, his willingness to accept calculated imperfection to achieve speed, influenced civilian welding practices throughout American manufacturing. The same principles that had saved tanks on an Italian beachhead later, kept factories running, enabled infrastructure repairs, supported the industrial growth that powered post-war prosperity. Military necessity had driven innovation that subsequently enriched civilian capability. Morrison returned to Nebraska farming in 1946, resuming the life interrupted by war. He operated a farm equipment repair business that became locally renowned for solving problems other shops declared impossible. Farmers brought him broken machinery others couldn't fix, trusting his reputation for making things work through practical wisdom rather than by-the-book procedure. He rarely discussed his military service, deflecting questions with characteristic modesty, insisting he had just done his job like millions of others. His customers knew him as the man who could fix anything, unaware that his skills had once saved a beachhead and influenced a battle that shaped history. The final assessment of Morrison's contribution to Allied victory at Anzio came decades later, when military historians with access to declassified documents and German archives could fully evaluate the counterfactual. What would have happened if the tanks hadn't been repaired, if German armor had faced unsupported American infantry, if the counterattack had succeeded in collapsing the beachhead? The consensus judgment was stark. Allied forces would likely have been driven back into the sea. Operation Shingle would have failed catastrophically. The Italian campaign would have stalled. The strategic consequences would have been devastating. 1. Farmers' improvised welding techniques, applied during 60 desperate hours, had prevented a disaster that would have reshaped the war's trajectory. Morrison died in 1987, carried to his grave secrets about Anzio he had never shared, modest about achievements that military historians would spend decades fully documenting. His obituary mentioned his Bronze Star in passing, noting his service in Italy without details. The larger story of how his practical wisdom and technical skill had enabled tactical victory, had prevented strategic disaster, had influenced maintenance doctrine and training programs, remained known primarily to specialists studying the Anzio campaign. But the men who had served with him, who had worked those desperate 60 hours, who had learned from his example and carried forward his approach, understood what had been lost. They had witnessed greatness that never sought recognition, competence that never demanded acknowledgement, leadership that never required rank to be effective. The essence of Morrison's achievement transcends the specific details of welding technique or tank repair. He demonstrated that formal expertise has limits, that credentials don't necessarily correlate with capability, that practical understanding gained through years of experience solving real problems under imperfect conditions can prove more valuable than theoretical knowledge developed in controlled environments. His willingness to trust his judgment against expert opinion, to take responsibility for unorthodox decisions, to stake reputation on techniques that might fail, represented a form of moral courage that enabled technical innovation. He succeeded because he refused to accept that impossible meant unachievable, because he understood his craft deeply enough to adapt principles to circumstances, because he trusted his hands and his experience more than he trusted the manual. The transformation Morrison catalyzed in the men who worked under him during those 60 hours represents his most enduring legacy. He taught them not just welding techniques but a way of approaching problems, a confidence in their own judgment, a trust in practical experience over formal procedure. They carried those lessons forward through the rest of the war and into civilian life, becoming leaders who valued innovation over compliance, who trusted subordinates' expertise, who understood that real capability came from understanding principles deeply enough to adapt them creatively. The ripple effects of his leadership influenced thousands of lives, shaped careers, improved organizations, contributed to post-war prosperity in ways impossible to quantify but undeniably real. The impossible welding that saved 200 tanks in 48 hours at Anzio stands as testament to human capability when confronted with circumstances that demand more than ordinary effort. Morrison succeeded not because he possessed superhuman abilities, but because he brought complete commitment to a task that mattered absolutely, because he understood his craft thoroughly enough to innovate under pressure, because he refused to accept expert assessment that success was impossible. His achievement validates fundamental truths about human potential, that we discover our real capabilities only when circumstances demand we exceed what we thought possible, that expertise comes from understanding rather than credentials, that the difference between impossible and merely difficult often depends on one person's refusal to accept defeat. The welds Morrison made during those desperate hours at Anzio held not just metal together but history's trajectory, preventing collapse that would have reshaped the war, enabling victory that opened the path to Rome and beyond. His story deserves remembering not for military triumph but for human triumph, for demonstration that practical wisdom matters more than theoretical knowledge, that craftsmen solving problems contribute essentially to success as soldiers fighting battles, that ordinary people doing extraordinary work under impossible pressure can change history's course. The farmer from Nebraska who became the welder who saved a beachhead embodied possibilities we all carry within us, capabilities we discover only when circumstances demand we become more than we thought we could be. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.